In this video, we're going to take a quick look at forecasting metrics and why they're needed and how we compute them. So let's go back over to the Excel spreadsheet. These are the questions and answers that you were provided in the worksheet. And so what we're looking at right now is we want to try to evaluate our current forecasting system. And that's the whole point of a forecast metric, is trying to track, if we're trying to forecast, how different from the forecast did actual occur. And so that's what's going on with our forecasting metrics. How close are we getting each month, or each time period, or however we're calculating it. So what I've asked you to do here in the questions is to take a look at the last 3 months, and using the last 3 months, this was the forecast. This is what we thought we were going to do. And here's actually what happened. 3 standard ways of looking at forecasting metrics. There's the mean absolute deviation, there's a mean squared error, and there's a mean absolute percent error. Here are the answers that I provided for you all already, but just in case, let me make sure that you know how to calculate these things. So the MAD is the mean absolute deviation, which really is just the absolute value of how much the actual and forecast varied. So if I'm going to go back to month 1, the MAD for month 1 is, it equals absolute value of the actual minus the forecast. And so looking at this right now, you can see that the absolute value of how much they changed really was 1. So that's going on there. I'm going to go ahead and just take this formula, and if I left click on the bottom, I can drag it across so that it goes ahead and calculates month 2 and month 3. Let's just make sure that this makes sense to us. Absolute value of the difference here is 1. Absolute value of the difference here is 2. Absolute value of the difference here is 2. Now if I'm looking at the MAD over the 3-month period, then what we're looking at is, what's the average mean absolute deviation for those 3 months. Whoop, and that came up as a percentage. Let's change that back just to a regular number. So there we have it. 1.67 is what's really going on. What does that mean to me? What it means is that on average, I'm off by 1.67 units over those 3 months. Hopefully that makes sense to you from that perspective. Okay, once again, that is just one way to calculate a forecasting metric. That's MAD. The next way for us to do it is, let's look at the squared error. So the squared error, let's go back here. We're going to take, instead of doing an absolute value, we're just going to take the difference between the actual and the forecast. So we're just taking the difference between the actual and the forecast, and we are squaring it. All right. So it came back 1 here, but as you can see, as we go forward, the difference between the actual and the forecast is 1. Squared becomes 1 still. The difference between 12 and 14 is 2. And whenever I square it, that is 4. Same thing here. Deviation of 2 here. Square it, that becomes 4. We take the average of all 3 of them again, and our answer comes out as 3. All right. The whole point here of the MAD and the mean squared error is that this says sometimes the actual is going to be higher than the forecast, sometimes it's going to be lower than the forecast. If we don't do something to take an absolute value or square it, the negative values are going to cancel out with the positive values, and it doesn't really give us a good idea of what's really going on with the error. It lets it kind of wash itself out. The last way we can look at this is through a mean absolute percent error. And so what we're doing here, we're going to once again take an absolute value as we did before, but this time we're going to take our actual minus the forecast, but now we want it to be a percentage um, of what we were really trying to forecast. So if we take and divide by the actual forecast, what we can see, I'm going to switch this over to a percentage. What we can see is that we have a deviation in our actual from forecast that's in a percentage. Um, the importance of that is if my forecast was 26 and 25, and we're only off by one, it's hard to compare a forecast of 26 back down to a forecast of 13. Or let's say that we're forecasting instead with 13 thousands. And just one item difference between 13,000 and 12,999 looks very different than being off by a full unit here. So if I switch things into a percent error, I can compare things regardless of what their base value is. Okay, so there's my MAPE for month 1. I'm just going to take and drag it across. There's the total for each one of them. I'm going to go ahead and expand this one digit so that you can see that the average MAPE for all 3 months is 13.5. That's why that's how we calculate the forecasting metrics. Now the reason that we're going to use these metrics and the reason that they matter to me is that I may be using one technique right now that's given me an average of 13.5% error. I might be able to go choose a different forecasting metric that might be able to reduce the amount of error that I'm getting. So the forecasting metric gives me an idea of should I go in and change to a different forecasting metrics or leave what I have alone. All right. Thank you for your time. We'll move on to something else.